Welcome back to the deep dive, everyone. We're here again to unpack some fascinating science for you. Today, we're tackling a question that, honestly, it might just flip your understanding of strength training kind of on its head. Ever wonder as simply testing your max strength, doing those 1RM tests again and again, could actually be enough to make you stronger? Or maybe what all those fancy strength metrics like velocity really tell us about your unique power profile? Well, we're diving deep into a pretty groundbreaking study today. It's titled Effects of Repeated 1RM Testing on Strength, Velocity, and Load Velocity Profiling, a repeated measurement trial. Yeah, it's a recent one, published in the Journal of Sports Science and Medicine. The authors are Florian Micke, Eduard Isenmann, Stephan Geisler, and Stephan Held. They're all from the IST University of Applied Sciences in Dusseldorf, Germany. And don't worry, if you want all the specifics, the full citation, link to the paper, it's all in our show notes. So our mission today, we want to pull out the really important nuggets from this research for you, help you understand the subtle stuff about testing maximal strength. We'll look at whether just testing acts like training and what these detailed measurements reveal about how your body generates power, especially, how different exercises might respond differently. Get ready to maybe gain a whole new perspective on measuring and developing your strength. Okay, so let's unpack this. When most of us think about measuring strength, like in the gym, the 1 rep max, the 1RM, it just pops right into your head.
Right.
It's the heaviest weight you can lift, just once, with good form. Super practical, everyone knows it. It's like the gold standard for a reason, right? A real cornerstone. But are we maybe missing something, by focusing only on that one number?
Yeah.
Especially with all the new tech and science coming out.
Yeah, what's fascinating here is exactly that. While 1RM is great, it gives us that absolute strength number, totally useful. But recent advances, they've brought in velocity-based metrics, and these really give us a much richer picture. We're talking about things like mean concentric velocity, MCV, at your 1RM, so literally how fast you move that heaviest weight. And then there's load velocity profiling. That maps out the relationship between the load, the weight, and how fast you lift it across different weights. These aren't just, fancy terms for scientists. They give us real-time insights into your neuromuscular function, how your brain and muscles are talking. Imagine tailoring your training based not just on weight, but on speed.
Yeah.
It's a much more nuanced view of capability.
That's a really powerful distinction. Function, not just the peak number. So, okay, 1RM testing is everywhere. It's foundational. What was the specific gap, the big question this study wanted to answer? What weren't we sure about?
Well, this is where it gets really interesting, actually. Despite how common 1RM testing is, there's surprisingly little known about the long-term effects of doing it frequently. Specifically, doing it alone without a separate structured training program on top. Think about it. You're pushing your limits regularly. Intuitively, you might think, yeah, I should be getting stronger, right?
Exactly.
But most research just looked at short-term reliability. Like, if you test today and tomorrow, do you get the same number? We didn't really know if just repeatedly testing without adding structured training stress keeps providing benefits, or if you just plateau. So this study, it was designed specifically to isolate that effect. Can the act of testing itself be a training stimulus, especially for people who already lift?
That's a super important question. Okay, so how did they set it up? Who were the participants and what did they actually do?
Right, so they recruited 14 resistance-trained men, average age around 25, and they had, on average, about 2 years of lifting experience. And that resistance-trained part is really important. These weren't beginners seeing those newbie gains. They had a base.
Okay.
And crucially, they were told to keep their normal training routines going, but, and this is key to avoid any specific periodization, no dedicated strength blocks, no hypertrophy phases, no bulking or cutting diets. That was essential to try and isolate the effect of just the testing, to stop other training changes from muddying the waters.
Got it. So no new fancy program, just their usual stuff plus these specific tests. What did the testing actually involve? Walk us through that.
Okay, so over a 7-week period, each guy did 5 1RM tests for both the squat and the bench press. The first 4 test sessions were weekly. Then they had a 4-week break and then came back for the final 5th test.
Okay, weekly, then a break.
Exactly. And they had a very standardized warm-up protocol each time. Tried to do the tests at similar times of day too, controlled for circadian rhythm stuff. They used an IMU, an inertial measurement unit. It's a device that precisely measures the mean concentric velocity, the lifting speed.
Right, the speed part.
Yeah. They usually hit their 1RM in about the 3rd or 4th heavy attempt. Squats had a specific depth requirement for good technique. And they were always encouraged to lift explosively, maximal intended velocity, even with the heavy weights. That's critical for getting good velocity data.
Okay, pretty rigorous setup. After all that testing, 5 sessions over 7 weeks, what was the big reveal? Did they get stronger just from doing these regular max tests? Did it work as a training stimulus?
Well, here's the headline finding, connecting it back to the main question. The study found no significant training-induced adaptations, not for 1RM strength, and not for the MCV at 1RM either, across all those sessions.
Wait, really? No significant gains?
Nope. Repeatedly doing these maximal tests alone didn't lead to noticeable improvements in their max strength or how fast they could lift that max weight. Any small ups and downs they saw between sessions were just trivial, within the normal day-to-day variability, not real lasting gains.
Wow. Okay, so what does this all mean? I think a lot of people, myself included maybe, would just assume if you're constantly testing your max, you must be training it somehow. Why didn't they get stronger? These guys were already lifters too.
Yeah, it really hammers home a core principle in exercise science, doesn't it? Progressive overload. For people who are already trained, the overall dose of stimulus from just these tests, it was simply too low. Think about frequency, volume, structured increases, just wasn't enough to force further adaptation. We know from other research that trained folks often need like at least 2 solid sessions a week, working around 80–85% of their 1RM with multiple sets to really drive strength gain.
Right, actual training volume.
Exactly. These 1RM tests, even though they're maximal effort, they were assessments. They weren't a structured progressive training stress. They lacked that consistent increasing demand. It's kind of like trying to improve your running endurance by just timing your fastest sprint once a week. You're measuring, but you're not doing the miles needed to build endurance. Plus, these guys weren't beginners. So those quick neural gains you see when someone first learns a lift, those were probably long gone. They needed a bigger stimulus.
That makes perfect sense. Testing isn't training, especially for experienced lifters. Okay, so beyond the 1RM number itself, the study also tracked VL slope and PP position, load velocity slope, and peak power position. Sounds technical. Can you break those down for us? What are they and what happened to them over time?
Sure. So VL slope, the load velocity slope, basically describes how your lifting speed changes as the weight gets heavier. Think of it like a graph. Load on one axis, velocity on the other. A steep slope means your speed drops off really quickly as it gets heavier. A flatter slope means you maintain speed better.
Okay, got it. Speed drop off.
Right. And PP position, peak power position, tells you at what percentage of your 1RM you produce the most power.
Yeah.
Because max strength and max power don't always happen at the same load.
Right. Power has that speed component.
Exactly. Now, what's really fascinating here is that the study found both the VL slope and the PP position stayed remarkably stable across all 5 testing sessions. No systematic changes over the 7 weeks.
Whoa, okay. Here's where it gets really interesting then. They stayed constant even with repeated max efforts. Why is that stability so important? What's the practical takeaway there for someone planning their training?
It's hugely important. The stability suggests these profiles your load velocity relationship or your peak power sets are pretty inherent characteristics. They're like a stable part of your individual neuromuscular fingerprint. They don't just drift around easily without very specific targeted training aimed at changing them. So this reinforces their reliability as fantastic tools for long-term monitoring. If you're a coach or even just tracking yourself, you can establish a baseline for these metrics. Then as you implement a training plan, you can track changes over months or years. And you can be pretty confident that significant shifts are likely due to your training adaptations, not just random noise from the testing itself. It gives you a reliable marker.
So it's a stable baseline to measure real change against.
Precisely. Now, it's important to say you can change these profiles with specific training, like targeted velocity-based work over a longer time. But the point is, they don't just fluctuate wildly on their own from week to week just by testing.
That's super useful for checking progress properly.
Okay, so far we've talked a lot about what didn't change significantly, the 1RM, the MCV, these profiles. But the study did find some key differences between the exercises. What did they see when they compared the squat and the bench press directly? Ah, yes, the exercise-specific differences. This is another critical takeaway. They consistently found, as you might expect, higher absolute loads and higher movement velocities in the squat compared to the bench press. For instance, that mean concentric velocity at 1RM, it was around 0.37 meters per second for the squat, but noticeably slower, 0.23 meters per second for the bench press.
So even at your max effort, you're moving the bar faster in the squat than the bench. That kind of makes intuitive sense, right? You feel stronger, move more weight in a squat. But what's the actual science reason behind that difference in speed and load?
Yeah, it raises that important question, why? It mostly boils down to two things: muscle mass involved and biomechanics. The squat uses a much larger group of muscles simultaneously: quads, hamstrings, glutes, back, core, just a huge network.
Way more muscle.
Exactly. That larger muscle mass can generate significantly more absolute force. Plus, the squat typically has a larger range of motion than the bench press. That allows for force development over a longer duration and distance, contributing to more total mechanical work. So, more muscle working over a potentially greater distance allows for heavier loads and, yes, even higher velocities at that maximal load.
Okay, that makes sense. What about the peak power position, the PP position? How did that differ between the squat and bench? And what does that tell us for training?
Right. The PP position was also significantly different. It was higher in the squat. Peak power happened at around 80.2% of the 1RM in the squat on average. But in the bench press, it was lower, around 65.6% of 1RM.
80% for squat power, 65 for bench. So what's the actionable piece there? If I'm designing my workout or I'm a coach, how does knowing that peak power happens at different relative loads help me?
Oh, it has really direct implications, especially if you're doing any kind of power-focused training or velocity-based training. It strongly suggests that for optimal power development, you should probably emphasize heavier relative loads in your lower body work compared to your upper body work.
Heavier for legs, lighter for upper body for power.
Generally, yes. So if you're doing power squats or maybe even certain Olympic lifts variations, your sweet spot for power might be in that, say, 60 to 80% of 1RM range. But for upper body power, like bench throws or explosive push-ups or med ball throws, you might find peak power occurs at lighter loads, maybe 30 to 70% of your 1RM press. Knowing this helps you dial in your training loads much more precisely if power is the goal. You're not just guessing, you're targeting the specific zone where that exercise produces the most power for you. Makes training way more efficient.
That's incredibly practical advice based on real data. Awesome. The study also mentioned something called minimal detectable change, or MDC. For anyone meticulously tracking their numbers, what is MDC and why is it important that it's different for squats versus bench?
Yeah, MBC is a really useful concept. Minimal detectable change. It basically represents the smallest change in strength, or whatever you're measuring, that you need to see before you can be reasonably sure it's a real improvement and not just random measurement error or daily fluctuation.
It's like the threshold for a real gain.
Exactly. It's the signal above the noise. The study calculated the MDC for the 1RM squat was 10.0 kilograms. For the 1RM bench press, it was 5.6 kilograms.
10 kilos for squat, 5.6 for bench. Okay, so what does that mean for me if I see my bench went up 3 kilos, but my squat went up 7 kilos? How do I interpret that using MDC?
That's the perfect application. Based on this study's findings, that 3-kilogram bench increase might just be noise. It's less than the 5.6-kilogram MDC, so you can't be confident it's a true gain yet. But that 7-kilogram squat increase, while it's less than the 10-kilogram MDC, it tells you you're getting closer, but maybe not quite definitively stronger yet based on that single measurement. You'd need that 10-kilogram jump in the squat to really say, yes, I've statistically improved beyond the test's variability.
Okay. So it sets realistic expectations for progress.
Absolutely. It's critical for accurately tracking progress. It stops you from getting overly excited about tiny increases that might just be random, or discouraged if you don't see huge jumps in exercises like the squat where the MDC is larger. You need to account for the specific variability of each test.
That's another super valuable point for anyone serious about tracking. Okay, like all good science, every study has limitations. What should we keep in mind here? And where did the researchers suggest future studies could go?
Right, important to consider. While it was well designed, a few things, there could always be some slight variability in how people perform the lift, even with standardized instructions. That could subtly affect velocity measures. Also, while participants were told not to change their training, their actual routines weren't strictly monitored or logged. So there's a possibility some unreported changes could have influenced things. It's sort of based on self-report there.
A potential confounder.
Could be. And they didn't separate participants based on performance level within that resistance-trained group. Would an elite lifter respond differently than someone with just 2 years' experience? We can't tell from this data. So future research could definitely look into that, comparing untrained versus elite lifters. Maybe use even more precise motion capture like AI or machine learning analysis to really nail down technique consistency. and maybe track outside training more closely.
Makes sense. Always more questions to answer. Okay, so wrapping this deep dive up. We've seen pretty clearly from this study that just repeatedly testing your 1RM on its own probably isn't enough stimulus to drive significant strength or velocity gains, especially if you're already trained. That really challenged the idea that testing is training. The study says, nope, not really. But it also strongly confirms that those velocity metrics like VL slope and PP position, they're remarkably stable, making them really solid tools for tracking your neuromuscular profile long term.
Exactly. And we learned those crucial exercise-specific differences. Squats generally involve higher loads and speeds, and peak power happens at a higher percentage of max compared to the bench press. That directly informs how you might set up your power training differently for upper and lower body. Plus, understanding that minimal detectable change, knowing you need about a 10-kilogram jump in the squat, but maybe only 6 kilograms in the bench to be sure it's real progress, that's vital for interpreting your results accurately.
So what does this all mean for you listening? If you're lifting weights, coaching athletes, this knowledge is gold. It helps you refine how you assess strength, maybe looking beyond just the 1RM. It underscores that you need specific progressive training overload for real adaptation. And it highlights that different exercises have unique characteristics you need to account for in your programming, especially for power. This deep dive hopefully gives you some powerful tools to make your training smarter. Now, we've really just scratched the surface here today. There's way more detail in the actual paper. So if you want to dive even deeper into the methods, the stats, all the nuances, we highly encourage you to read the full article. Again, it's Effects of Repeated 1RM Testing on Strength, Velocity, and Load Velocity Profiling, a repeated measurement trial by Micke and colleagues in the Journal of Sports Science and Medicine. If you found this deep dive valuable, and we hope you did, please make sure to follow our channel. Turn on those notifications too so you don't miss our future deep dives where we keep breaking down complex research into actionable insights for you. Until next time, keep learning, keep applying what you learn, and keep getting stronger.